session of the short course training session for satellite remote sensing course for satellite remote sensing. So these sessions are organized by the MS Satellite Meteorology, Oceanography, and the Climatology Committee, we call SATMAC Committee. And in the past half year, the committee members has worked almost regularly in every 2 weeks to discuss the materials and plan the time and work out the logistics for those sessions. So the purpose of this training session are to provide an opportunity for our students during the summertime to learn new and interesting satellite applications enabled by the research activities in the federal labs and in the universities. It's meant to be the materials that you're not going to learn in a textbook, because the satellite remote sensing is a very fast evolving field. So these sessions will bring new and fresh data product and science and materials to you. We also think that this opportunity could also be interested in those who want to moving into this satellite remote sensing area, and so those training sessions will enrich your background and your background in satellite remote sensing. My name is Jun Wang. I'm a professor in the chemical engineering department here in the University of Iowa. Also joining me here are several SATMAC members that has been planning those sessions. And so today is our third of four sessions that we plan for this summer. The session will be led by Joseph Penner and also Sherry Morris. The topic is really about the unique pathways in the field of satellite remote sensing. And Joseph Patton is an assistant research scientist with the Kropp Institute for Satellite Earth Science at the University of College Park. He has done a lot of work in the National Weather Service, including also work with the NASA forecasters at the Kennedy Space Flight Center for developing operational techniques for forecast lightning during around the sunstorms. Very important for satellite launch, obviously. And he held a bachelor degree in meteorology from University of Oklahoma and a master degree in meteorology from Florida State University. And so a lot of diverse research career background and career pathways that he has already experienced. Miss Sherry Morris is the GOES-R's satellite training coordinator and a user liaison contractor for the GOES-R product readiness and operation team inside the NOAA NESTIS. And he has a lot of experience. She has a lot of experience and develops, plans, and organizes and implements the technical meetings, satellite training courses, and as well as NOAA WMO international workshops and webinars to increase the use of GOES-R data and other satellite products through the training sessions. So very versed in the training and lots of experience and knowledge within the community, in the satellite remote sensing community. Her master degree is in marine biology, and she enjoys applying oceanography knowledge to satellite data analysis and training users in numerous ways to assess, analyze, and apply satellite data and products. So with that, Sharon and Joe, you take away from here.
Well, thank you so much for that introduction. That was a great start to our short course here. Like Jun said, I am Joseph Patton. I work at the University of Maryland, and my co-host today is Sherry Morris. Go ahead.
Go ahead, Joseph. It's fine.
Just gonna say, I'm just gonna let you introduce yourself, but Sherry Morris from STC or NOAA NESTIS. And as the title suggests, we will talk about a wide variety of opportunities that are available in working with satellites. Although this is a long 2-hour session, we encourage you to ask questions and participate, and we will try to answer them as we go. So post your questions in the chat if you'd like. there are a few big takeaways that we want you to keep in your mind while you're listening to this. And one is to, keep an open mind. There are many ways to forge your path that may not be exactly what you want, but you can do whatever you would like, regardless of your education or your age or your school level. You just have to put your mind to it. And the next is that, like I mentioned, you may not know exactly the next step you want to take, or you may not see where the next step will take you, but that's okay. The next step doesn't necessarily have to be your end goal, but it can help you achieve that goal. And then finally, if you see a job that interests you, go ahead and apply for it. Even if you think that you might not necessarily meet all the qualifications, that's up for the potential employer to decide if you are the right candidate. And even if you don't have all the required skill sets, you may still be the ideal candidate for that job. Finally, there are so many different avenues to work with satellites. We're going to talk a little bit about them today. And the goal is to help you get where you want to go next.
And I will, they said to try to do the introduction bio quick, but I've been working for a long time, over 4 decades. So my path took me, I let the path take me, so to speak. So I was an undergrad as a pre-vet major, and I applied for an internship at the National Aquarium in Baltimore. I did not get the pre-vet internship. Instead, they offered me a herpetology internship, which is working with frogs and snakes. And I love frogs and snakes, so I said, sure. Well, it turns out I did work with the poison dart frogs in Central America and South America. So that was a lot of fun. And while I was doing that internship, I met the lab chief of bioorganic chemistry in one of the line offices at the National Institutes of Health. By the next summer, my major was biochemistry and molecular biology, and I was doing an internship at NIH on natural products research, which is the alkaloids and the toxins in these poison dart frogs. So after I graduated undergrad, I worked at NIH for years and then decided to go back for my master's and took a 9-to-5 job with the Nature Conservancy's International Trips program to go to grad school at night for my degree in marine biology. So I got to travel all over Latin America and the Caribbean for work. And then after I got my master's, I started working at DynCorp, doing chemical method validation studies with EPA. I eventually ended up at Booz Allen Hamilton doing EPA contracting work as well as the Veterans Health Administration work. At some point, the Carlyle Group bought out Booz Allen Hamilton and did a large layoff of a large portion of the staff. So I was out looking for a job again. And I had a LinkedIn profile and I saw a job listed under Science and Technology Corporation. And the person that had posted the job opportunity was linked a first connection to my boss that I had worked with at DynCorp. So I emailed the boss, the former boss, and I said, hey, can you put in a good word for me? Well, he did, and that's how I got the job interview. The posting at STC was for the National Weather Service. I did not have a meteorological background. I did not have experience in weather, but I had the chemical background, I had the math background, and I had the skill set that I could do the job in that office. So I was hired. So after about 5 years or so working in that office, STC had an opening at the GOES-R program office working with satellites. So it turns out I grew up outside of Annapolis where Goddard Space Flight Center is. My brother works at Goddard on satellites. I have plenty of friends that work on satellites. I've gone down to many launches, including the space shuttle, 4 or 5 of those launches. So I knew enough about satellites. That doesn't show up on my resume. But when I told my boss at STC that, yeah, I can talk satellites, I can talk enough satellites that I can do the interview, and I got this job. And it's the best combination of my background, I work a lot, as June said, with the Central and South American community, and I was exposed to a lot of their cultures and I understand a lot about them because of my travels from the Nature Conservancy like 30 years ago. So you just don't know how, as you're building your career, how it will feed into the next step. And that's what's also important here. We're going to talk a lot about different opportunities, where you can look for jobs, a lot about how to work with satellites. But that's the goal of this. What do you want to do next? And again, as we're going through this, please go ahead and enter any questions into the chat. While Joseph's talking next, I will monitor the chat.
All right. So a little bit about my background. You heard already that I went to the University of Oklahoma and Florida State University for meteorology, but really I knew meteorology was for me probably by the time I was 5 or 6 years old. I had composition notebooks where I would write down random weather observations for the day, like, oh, June 21st, 2 p.m. it rained today. And I didn't know what I was doing, but I knew that I had a passion for atmospheric science. And, I grew up along the Gulf Coast of the United States, on the northern side of the Gulf of Mexico. And our main hazard in that area is tropical cyclones or hurricanes. So that was a very formative weather phenomenon for me growing up. In fact, in 2005, I decided I was going to make a journal documenting all of the tropical cyclones that occurred in the North Atlantic basin. And little did I know that that would end up being the most ever named tropical cyclones or tropical storms and hurricanes ever for that basin. And I remember being frustrated as a kid because I didn't have enough colored pencil colors to give every storm its own color. And so, yeah, that was a very historic year, a very formative moment for me growing up. That year included Hurricane Katrina, which made landfall not far from where I grew up in South Louisiana. And so it was a very historic event to go through. At one point we had 11 people staying in my house just because they didn't really have anywhere else to go home to. They were from New Orleans. So we were lucky in that respect, but it really put into perspective the impact that extreme weather events can have. And that gave me my passion to be in meteorology still today. So, I didn't really have an emphasis in meteorology from an academics standpoint when I was in high school. I know a lot of people these days get involved fairly early, but I really sort of hit the ground running when it came to going to the University of Oklahoma. I started right away with meteorology and advanced math classes, and I was active in clubs, and I even went out to do some storm chasing. Oklahoma is in Tornado Alley for the United States. And I also had the opportunity to take a semester abroad. I went to Monash University in Melbourne, Australia, for a semester studying atmospheric science. And we got to do some interesting experiments there. That was a lot of fun. And, just forecasting weather in the Southern Hemisphere is a whole different, it's a whole different perspective when you're used to the Northern Hemisphere. So that was great. And then I went on to Florida State for grad school. I got my master's in meteorology, and I worked a student internship with the National Weather Service. I'll talk more about that in a little bit. But that area was in Kansas, Goodland, Kansas, also in Tornado Alley, and it was just a thrill to be in an area that got so much diverse weather from tornadoes to blizzards to dust storms, and it kept us busy all year round for sure. So currently, I'm a full-time faculty research assistant at the University of Maryland. I don't teach any classes, but I am a professional track faculty working under contract for the Cooperative Institute for Satellite and Earth System Studies. And we'll talk more about cooperative institutes in a little bit. But my work is currently contracted through NOAA to help support the relatively new instruments called the geostationary lightning mappers, which are on board the GOES-R series geostationary satellites. And so because they're in geostationary orbit, they're always looking at the same place the whole time with continuous coverage for most of the Western Hemisphere. So the GLMs are really first of their kind instruments to map the spatial extent and count and brightness of lightning flashes in a continuous coverage way. And those can be really key data points for forecasters from the National Weather Service or other meteorological agencies to make decisions about watches and warnings for convective hazards. So I'll talk a little bit more about my specific career path and what projects I got involved with in a little bit, but that really sums up my experience so far. So we want to show this slide just to emphasize how much of an international community the weather satellite enterprise is. You know, there are many countries involved, there are many organizations involved, and you know, this chart shows most of the satellite weather environmental satellites that are in operation currently. There are dozens of satellites in low Earth orbit or near polar orbit, which is the red circles here, and they are relatively close to the surface of the Earth, so they can get high quality, high resolution images. But they are also only passing over a specific area once per day at the same time every day. So you don't get that continuous coverage. But they have an altitude of about 800 kilometers above the ground, and most of those satellites are either focused on observations of the Earth or observations in the atmosphere. The satellites are in the exosphere at 800 kilometers, so some of them make measurements there and some of them look at lower levels in the atmosphere. But there are also dozens of satellites in geostationary orbit, which is the blue circle here. And it's much higher up with an altitude over 35,000 kilometers above the ground. And so that means these geostationary satellites often have a lower spatial resolution because of their higher orbit, but they also are able to maintain that constant look over the same area over a long period of time. So the satellites are generally situated at the equator, and they orbit with the same speed as the rotation of the Earth, so they're always looking at the same space. Some of the instruments on board the geostationary satellites are pointing at the Earth's surface and make observations of the Earth's atmosphere, but they can look at different electromagnetic bands to assess water vapor and brightness temperature from certain features in the atmosphere. But some of the instruments are also pointed towards the sun, and they're measuring things like the location of solar flares, the intensity of the radiation that's coming from the sun, and any changes which may indicate that there's some harmful activity coming towards Earth. So the GOES-R series satellites, which stands for Geostationary Operational Environmental Satellites, they also include a magnetometer instrument for making measurements of the Earth's magnetosphere and particle and ion fluxes. So there's lots of instruments, lots of different satellites. And then in addition, in the top right there's a handful of satellites with a heliocentric orbit around the sun, which provide important measurements from the sun as well. So these spacecraft allow NASA and NOAA and the European Space Agency to monitor the corona from the sun, the solar wind, and changes to the surface of the sun over time. So these are just a few examples of environmental satellites currently in orbit. And we want to show this just to really hit home how much of an international community this is, with countries from the US to Japan to India to China to France. So it's a large number of organizations which operate these satellites, and we all come together to make this happen. So we want to start off by going over some broad areas about how to be involved with satellites in the weather community. So one of the biggest ones is forecasting. If you're doing weather forecasting, you're making predictions about what kind of weather impacts are going to happen to a certain area over a certain period of time. One of those ways to be a forecaster is you can be an operational meteorologist for the meteorological agency in your area. It's the National Weather Service in the United States, but a lot of countries have their own version of the Weather Service. In addition, you can do a route through more academia and research. And in that aspect, you're either teaching others how to interpret satellite observations for forecasting or research so that they can attain the information that they need, or you can conduct your own research using satellite observations. So you can focus on interpreting those satellite observations or using them for different data analysis. One of the interesting things that I get to work on is we at the University of Maryland are running an experiment this summer to collect other observations which can validate readings from the satellites. So I work closely with the geostationary lightning mappers, or the GLM. And one of the things we're doing this summer is we have a camera network set up to record lightning strikes as they happen. And we can use those observations, those real observations of lightning, and compare it to things like the GLMs to verify that those GLM observations are legit, that they are capturing the lightning as it happens, and that they are at the right time and the location compared to what we're actually able to observe with running cameras. So organizations for academia research can include the universities themselves, or it can include cooperative or research institutes as well. And we'll get into a little bit more about cooperative institutes later. And then finally, just as a broad category, there are a lot of more examples, but just as a broad category, there's also satellite operations, where you work with maintaining the satellites currently in orbit, such as performing orbital maneuvers. You can upgrade the software or process data before it's used for forecasting and research. And that really falls in the United States under the heading of the organization known as the National Environmental Satellite Data and Information Service, or NESDIS. We want to show a little bit about how NESDIS works as well, just to give you an example of that satellite operations. So NESDIS's goal is to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life. So it's really a broad kind of mission there, but specifically they do operational processing and dissemination of data. They also have a lot of responsibilities when it comes to data stewardship and archiving. So making sure that the right people get the data and that they keep a historical record of that data, in addition to quality control, quality assurance. So one of the things that they work on is developing algorithms to display the right information from the right products, and also have the right system set up to where these satellite observations can be assimilated quickly into things like numerical weather prediction, and then validating or calibrating the satellite instruments as well. And part of what we were doing with the camera network is validating those satellite observations. So they're also planning the next generation of geostationary satellites for the United States. And instead of 2, there will be 3 this time. So there's a lot of planning that goes into that, and writing the right documents to ensure that these satellite observations are going to be made correctly. So that's just NESDIS as an example. So we want to jump in from here into some meteorological applications for satellite data. So if you were using this from a meteorological sense, how would you, in what ways would you be applying it? And the main one is for monitoring active weather patterns and issuing forecasts and warnings. The GOES-R series satellites, as an example, they have instruments which detect cloud top heights, water vapor at different levels of the atmosphere, lightning strikes with the GLM, and a lot more. And part of an example of active weather patterns that you might be observing would be hurricanes or tropical cyclones, floods, tornadoes, severe thunderstorms. So all those kind of convective hazards as well. And really, in that role as a forecaster, you often provide support for response to natural and man-made disasters. So you're making specialty forecasts to help people respond to weather after they've happened as well. And that includes for fire weather, monitoring the fire spread and intensity can really help direct firefighting resources to the right location and keep them out of harm's way from other potentially hazardous weather, and keep people safe and protect property as well. So for the fire weather applications, one of the instruments that we wanted to highlight is the VIIRS instrument, which stands for Visible Infrared Imaging Radiometer Suite. And that sensor is aboard the Xiaomi MPP and NOAA 20 and 21 satellites. And it's very skilled at detecting hotspots from fires, especially at night, where the bright hot fires shine well against a darker, cooler background. And that image on the lower right-hand side is from the VIIRS instrument from fires burning and the smoke that they were creating in California in October 2017, which was a particularly active fire weather period for them. So that's just one of the instruments that you could use for that application. In addition, there's ice monitoring. So one of the important aspects of meteorology is being able to monitor exactly where the lake and sea ice extent and concentrations are. And those are often derived from microwave imagers on board polar orbiting satellites, for example, JPSS, which stands for the Joint Polar Satellite System, that's from NOAA, and the DMSP, which stands for the Defense Meteorological Satellite Program, which is a series of weather satellites that are stewarded by or created by the Department of Defense in the United States. So if you were involved in session 3, you may remember that they were working on using satellite observations to monitor sea ice to see if the Northwest Passage would be open. So that is just one example, a perfect example of how satellite data can be applied in that situation for ice monitoring. And then there's also atmospheric composition and sounders. So many satellites measure the concentration of different particulates in the atmosphere, as well as air quality and the vertical profiles of temperature and water vapor in the atmosphere. And there's always future launches that are going to be happening as well. Many launches are planned for the next couple of decades. One of them is the Maya instrument from the Jet Propulsion Lab from NOAA. And Maya stands for Multi-Angle Imager for Aerosols. And that's just one of the new satellites that's coming up that's particularly interested in measuring aerosols as well. And then there's the Ozone Monitoring Instrument, or OMI, aboard the NASA Aura spacecraft that measures ozone, as its name would imply. So there's lots of different applications here. We said the Northwest Passage for ice monitoring, for fire weather. Even energy companies need to know the impacts from fire weather. Maybe they need to turn off certain parts of the grid or something like that. So there's lots of different applications here. In addition, we can have satellite applications in other industries as well. So, for example, the marine industry, from fisheries to shipping activity, it includes a lot of different things. One of the products that is particularly useful from a satellite data perspective is Ocean Color, and the Ocean Color product is produced from observations from that VIIRS satellite, and they provide vital information on the presence of phytoplankton and algal blooms, which can negatively affect fish populations and human populations as well. The VIIRS instrument can be used to monitor illegal fishing because it's really good at spotting those brightly lit ships, especially at night, against the dark background of the ocean. And those ships may be fishing illegally depending on their activity. And then also the Sentinel-1 from the European Space Agency can map ship locations using a C-band synthetic aperture radar. And that Sentinel-1 satellite can also show things like oil spills, which can be very important for disaster response. So under that marine subheading, there's ocean currents, wave heights, sea surface temperatures. These are all different things which are tracked using a combination of satellites. And if you're interested to see some of that marine data, we've got the link there, and when we will post these slides afterwards along with a resource document as well. So all the links in here will be you'll have access to after the presentation. And some of them we'll try to post in the chat as well. But Coastwatch there is NOAA's data delivery system for maritime applications, and their goal is to really put this data in the hands of the right people who need it. And then there's also the Ocean Prediction Center, which is part of the National Weather Service. Their focus is on creating marine forecasts and warnings and surface analyses for ocean shipping traffic to help keep them safe as well. So there's lots of different applications from a marine perspective. So a few more satellite applications. There's space weather. So we talked about those instruments which are facing the sun in particular. They monitor the solar wind and solar flares from the sun, which often have impacts on Earth. They can do things like cause communication blackouts or damage to satellites or astronauts who are in orbit. So it's very important that we are able to monitor space weather with different instruments. The image there in the top right is from the GOES-18 or GOES West satellite, which is situated over the western half of the United States and the Eastern Pacific. And one of the instruments on there is the SUVI instrument, or the Solar Extreme Ultraviolet Imager. And that instrument specifically observes the hot outer atmosphere or the corona of the sun for coronal mass ejections, which are the phenomenon that can lead to some of those impacts on Earth. And then there's also a similar instrument on board the Chinese satellite Fengyun 3, which has a similar purpose, the Solar X-ray and Extreme Ultraviolet Imager. One of the other major categories is forestry, land use / agriculture. Just as an example, there are dozens of small satellites called CubeSats, which have been launched by Planet Labs, which is a private company here in the United States, which capture high resolution images of the land areas on Earth to show logging and land use changes. So that's what the imagery there is in the lower right. There's a before and after image of a particular section of a wooded area before and after some of those trees were cut down for logging. So it allows private companies to understand and map how they're going to be approaching that industry, and then it also allows for governmental or oversight agencies to make sure that none of that activity that's happening in forestry and land use is illegal or against regulations. And we also just want to say that these are just some of the examples that we have seen, and we don't endorse any particular companies. We just want to mention these as an example. So under that agriculture or land use subheading, lots of satellites are able to observe vegetation index based on their observations, and that can show how much vegetation is growing in an area and how healthy it is and what type of vegetation is growing. So those are all very important to that industry. And then also there's the aviation industry or aviation operations, which are these satellite observations are very important for. So agencies like the Federal Aviation Administration or FAA in the United States, or the Directorate General of Civil Aviation, DGCA in India, and other countries or regions which have their own aviation administration, those people who are controlling the air traffic, they rely on being able to interpret weather satellite observations in order to route planes safely. So, to a pilot, every thunderstorm is a severe thunderstorm. So they really rely on those satellite observations to give them an idea of where planes should be routed around to get to their destination safely. So I want to talk a little bit more specifically about my career path. So I've said before that I got my bachelor's of science in meteorology from the University of Oklahoma, and my master's of science in meteorology from Florida State University. But you know, there were a lot of things I did during that time to help further my career as much as possible. So one of the things was, while I was at the University of Oklahoma, I got involved as I could as a student. I participated in the Oklahoma Weather Lab, which was a student-led forecasting group for the OU's campus, which gave me some experience making my own forecast for the first time. I ended up doing some collaborative research with the Center for Risk and Crisis Management, which is part of the Cooperative Institute there at the University of Oklahoma. And that project was really looking at all of the geolocated tweets that contain the word hail. And what we were trying to do was sort of make a crowdsource of where hail was falling in real time. So we used a machine learning algorithm to try to parse out tweets which weren't about hail, but still contain the word hail. For example, the country Thailand, THAILAND, contains the letters hail inside of it. There's also phrases like hail to the king, hail to the victor. So we wanted to teach a machine learning algorithm to filter out those kind of tweets and only keep the ones that said something like, oh, I just measured hail and it was 1 inch in diameter, something like that would obviously be about hail. And we were able to create, along with radar and satellite observations, a pretty realistic example of how those tweets would show up in real time for a convective thunderstorm moving through a populated area. So it was an eye-opening experience to see that you can crowdsource some of that data as well. That research like that is a really good example of how to be involved in meteorology and even social science when it comes to making decisions like that. So after OU, I went to Florida State, and I think it was briefly mentioned in my introduction that I did my research there was on making a probabilistic forecast guidance for thunderstorms which are decaying, to try to see if they're going to be continuing to produce lightning strikes. And that was for Kennedy Space Center from NASA. And, they use it to protect life and property. They don't want anything out in the open that could get damaged when thunderstorms are coming through. And thunderstorms are a frequent occurrence in Florida where Kennedy Space Center is. So that was something they were really, really interested. If they could know for certain that a thunderstorm was going to stop producing lightning in 5 or 10 minutes based on radar observations and satellite observations, then they can get people out more quickly, and they can reduce the amount of time that they have to stop working in order to be safe from lightning, from thunderstorms. But I didn't get to start that right away. My first semester on campus at Florida State, I was a teaching assistant, and I was teaching an introductory lab for meteorology for non-majors. So I have a little bit of that teaching experience as well. And then while I was at Florida State, I was able to secure a student volunteership with the National Weather Service there in Tallahassee, Florida. And it wasn't a paid thing, I was just a student. It was a volunteer position, but I got really invaluable experience on how to make forecasts, how to make up and launch weather balloons, and how to interact with the public to help spread awareness about different meteorological hazards and what they can do to keep themselves safe. So after I graduated Florida State, I spent about 6 months to a year looking for the right spot for me in the National Weather Service. There was a lot of applying and interviewing, and then I was finally offered a position with the National Weather Service office in Goodland, which is right in that Tornado Alley region of the United States. And I got lots of invaluable experience working with that and satellite data, everything, from thunderstorms to blizzards to blowing dust to dense fog to snow squalls. And I worked there for about 2 years before I moved to Washington, D.C., the capital of the United States, for family reasons. And I spent a few months working odd jobs here and there to help make ends meet like working at an Amazon warehouse or tutoring students online. But those eventually led me to my current position, which is as a faculty researcher at the University of Maryland. And how I got this position is kind of interesting. I was actually contacted through a message on Twitter by my current supervisor to gauge my interest in this position. And the reason he knew me in that sense was that we had the same major professor at Florida State University, just 10 years apart from each other. And so it really ended up being one of those things where it's all about who you know and the networking that you can be involved with there. You know, it was one call back to that major professor who said, yeah, he's cool, and then I was able to get this job. So that was that really shows the importance of that when you're looking for your next step in your career. And you know, I talked a little bit about what the geostationary lightning mappers do, and you know they're calculating these lightning flash characteristics every minute aboard the GOES-R satellites, and the animation that I want to show here now is actually from some of those GLM observations. So what's being overlaid here is planes that are being routed by the FAA around and through these thunderstorms, and the GLM flashes are there in the blue and yellow and orange colors there, and they really show the spatial extent and the count of the flashes in this example. And one thing that's interesting is you can notice how the planes are mostly really being diverted to avoid this large convective hazard, which could pose a threat to the planes. But some of them are flying right through. A lot of them are looking for breaks in that convective activity, and those breaks are more evident when you can see the break in lightning as well. So they're often shooting those gaps between groups of different lightning strikes. Okay, so for our next slide, I think we want to go to our first speaker for today, which is whose name is Wayne McGarry, meteorological specialist at the Caribbean Institute for Meteorology and Hydrology in Barbados. So I will stop sharing and then allow him to share his screen.
Thank you so much, Joseph. I'll go ahead and share my screen now. Oh, can you see my screen?
Yes.
Yes.
Fortunately, my video not be able to run, but good afternoon, everyone. It is a pleasure to be here. Satellite related information and satellite meteorology is a passion of mine. As was said, I'm a meteorological specialist at the Caribbean Institute for Meteorology and Hydrology. And I just want to give a bit of background about my institution before I proceed. So the Caribbean Meteorological Institute, this was established in 1967. And this was by the member states of the Caribbean Meteorological Organization. While the Caribbean Operational Hydrological Institute, this was established in 1982. Now, the two institutions were amalgamated in the mid-1980s. However, they maintain the name, the Caribbean Meteorological Institute. But this, however, was changed in 1999 of September to reflect the dual role of the institute, and it became the Caribbean Institute for Meteorology and Hydrology. Now, it is the technical organ of the Caribbean Meteorological Organization, and they're actually globally recognized as a WMO Regional Training Center for the Caribbean, RTC. We also are a center for applied research and development in meteorology, hydrology, water resources, climatology, and related areas. So things like DRR, disaster risk reduction, and impact forecasting as well. We are also a regional instrument center for the Caribbean. where instruments across the region are maintained by the Institute. Also, a WMO Center for Excellence training in satellite meteorology. Additionally, the Regional Climate Center for the Caribbean Center for Climate and Environmental Solutions, a data archive as well for the CMO member states. And we also are the Pan American Center for the WMO Sand and Dust Storm Warning Advisory and Assessment Center. Actually, we have a nice team here who have become quite well known. This is spearheaded by Dr. Andrea Seeley, and some of her other team members are Mrs. Rebecca Chewett Lucas and Ashford Reyes, who also does modeling, Dr. Reyes, who also does some modeling. Now, a little bit more about our primary functions. We provide facilities for training of various categories of meteorological and hydrological personnel. And we do have an image here of some students from the hydrological section who are being trained. One of our colleagues as well here with an automatic weather station. We operate as well as a center of research in meteorology and hydrology and associated sciences. And we also are contractors and consultants on various meteorological and hydrological projects. And we also maintain a service for upkeep, repair, and calibration of meteorological instruments, as I was mentioning. And that is done across the region by our main instruments guy, Mr. Marvin Ford. And we also provide advice to participating governments on meteorological and hydrological matters. So we do provide briefings and updates when there are tropical systems in the area, of course, for critical decision making. This is the like SEDEMA, the World Bank, and organizations such as that. And we also collect, analyze, and publish meteorological and hydrological data. And we have here 16 CMO member states that make up for the CMO. All right, so just about myself, my educational background. I did my bachelor's in meteorology and a minor in computer science. I completed that in 2014 at the University of the West Indies, Bayfield campus. Later did my graduate studies. I did my master's in applied meteorology and climate risk management at the University of Reading in the United Kingdom. Now, in my current position, I am a meteorological specialist. My responsibilities, these include lecturing, training courses, maintaining meteorological technicians training in accordance with the WMO standards. Also, I support and promote research and development activities in accordance with the CIMH mandate. So we have interns who supervise interns who oversee some research that they're doing, but also we do individual research as well. We also provide severe weather updates to CIMH stakeholders. So as I said, SEDEMA, World Bank, under certain adverse conditions, we will provide them with updates. Prepare reports as well and briefings for internal and external agencies, or rather I do that and represent Institute as well at regional and international meetings, workshops, seminars, and so on and so forth. So, and again, as I said, initiatives for CNA. But how do I get here? So my interest was actually sparked in 1995. We had a very significant weather event. It was a trough system. This provided some significant flooding across the island, and a very famous singer by the name of Karu, Calypsonian, he actually unfortunately drowned in this event. And at such a very young age, I remember that stuck with me, and it kind of really piqued my interest in the field of meteorology. So I began working though later, throughout my life, I took a special interest geography, but later realized that meteorology was a lot of physics and mathematics and not as much geography as I thought as a younger person. But I began to work at the Barbados Meteorological Service in 2003. And later I decided I was going to pursue my bachelor's degree in meteorology with a minor in computer science. It's actually during my studies at the University of the West Indies, I took a keen interest in satellite meteorology, and I wanted to do a little more within that area. So I worked at the Barbados Meteorological Service for 18 plus years. In my later time there, I developed a website where I generated some satellite products, which were used to aid in our impact-based forecasting at the time, and also in terms of analysis of the weather. As you know, we're surrounded by lots of water, so satellite imagery and satellite data is quite useful for us here across the region. So I began my role at the Caribbean Institute for Meteorology and Hydrology, CIMH, in 2021, where, as I said, began to train persons. And actually, there's a course that's being developed. We begin in 2024. We'll be training persons in utilizing the satellite data, the NetCDF data, to generate imagery, to do analysis. So that is a course I'm excited about conducting come 2024. But along the way, I did take part in some critical training, did a workshop on hurricane forecasting and public weather service at the National Hurricane Center. That was where, again, satellite imagery and satellite data was utilized. I did an international training course on the applications of meteorological satellite products. So this was in China, at the China Meteorological Administration. And actually my introduction into the generation of satellite products, this occurred in 2018, where we had a workshop on severe weather forecasting, and we looked at severe demonstration project along with numerical weather prediction and public weather service. And it's there where Diego Souza, he's from the Institute for Space Research, he did some work with generating products using the raw NetCDF data, like RGB products and various satellite products. And that is where I really fell in love with that and found it quite useful, because it's very useful. And I listened to what Joseph was saying in terms of research and analysis. And so there are some products that would have generated. We have here the cloud phase distinction RGB, and this is very useful to identify convective initiation. So this is a useful tool. And we have here the rain rate product. So this can give you some idea of some rain rates, some real-time rain rates, and it can be useful for nowcasting, and even give an idea if you're looking at making some forecasts as well. Can be quite useful. We also have here the SO2 RGB, which was quite useful during the La Soufrière volcanic eruption in 2021. And we can see here the benefits of this product. It's also a product that I've been working on recently. This is the convection, where I've fused it with the nighttime microphysics, so that when the sun, because it's an imagery that utilizes predominantly visible imagery at night, the imagery will go dark. So I've put it together where the nighttime microphysics RGB comes into play at night. So this is just an idea, some of the products that been using in terms of satellite products. And satellites, honestly, with the improvements in satellites, have really been helpful in recent years, and we've definitely been able to utilize them to aid our forecasts and to improve our forecasting and even nowcasting across the region. So thank you. Any questions for me?
And Wayne, if I can ask you to provide a little bit more information on the 2024 course, we can include that information and distribute that to the attendees of this course.
Okay, sure. So ideally so the date is not finalized as yet. The aim is for January, but what we're looking at doing is persons who have GeoNetCast systems. We're looking at utilizing the data, the level 2 data that the GeoNetCast provides, and you can generate a range of products. This will include RGB products. You can also utilize products where we overlay some model data with some real-time data as well over satellite imagery. So the idea is to get persons to have a better understanding of what tools are available in terms of utilizing the satellite data for research, to improve their forecasting as well. So that will be around January, but we ultimately will be doing is utilizing GeoNetcast level 2 data, and I'll be teaching persons how to generate those products using Python.
Thank you.
But more information will follow because the date has not been quite finalized yet.
And we'll talk about training in the second half, but there's always opportunities to attend additional training. Really just helps build your background and portfolio. So training also helps in that sense as well.
And Sherry, what I can do is provide you with the information once it's finalized, and you can distribute it as well. Okay?
Perfect.
Right.
Thank you, Wayne.
You're welcome.
And I see Barb has gone on camera as well. To help in the bandwidth, I will turn my camera off while Barb is talking. And Joseph, if you want to go ahead and share your screen again for Barb's slides. Thank you. And Barb, do you want to go by Barb or Barbara? I should have asked you that ahead of time. If you want to describe your
Barb is fine, thank you.
So go ahead, Barb.
Okay. So thank you so much for bringing me in to talk. And I'm going to come from a different background to talk a bit about how we are using satellite. Well, how I have through my path, and also how we do within the National Weather Service. So my name is Dr. Barb Bausted. I sometimes go by Barb Mays Bausted. And I work for the National Weather Service in a piece of our training group called the Warning Decision Training Division. And our role is to prepare our workforce to work on the high impact weather events like tornadoes, severe thunderstorms, flash flooding, and winter storms. A little bit about me. I'm going to actually echo a little bit of Joseph, that a lot of my interest in weather came pretty early in my life. I think I was about 6 years old when I told my mom I want to be a meteorologist when I grow up. I was one of those kids who was afraid of storms, and to get me to be less afraid, my mom brought me to the library so I could learn about them. And I ended up checking out every book, reading everything I could, and becoming fascinated with weather, especially high impact weather. So I had that interest for a long period of my life, but it hasn't been my only interest for a long period of my life. And here's where maybe I'm a little bit more like Sherry, that I have a lot of interests and they overlap. Because in addition to my interest in weather and relatedly in climate, I also have interests in communication, writing, for instance, and speaking. So when I went into school, I ended up with 3 majors in college because I couldn't choose and I didn't want to choose. So meteorology and geography were my majors. I couldn't get a climate major or minor where I went to school at Central Michigan, but I took some climate in there too. And I also got a major in English because I wanted to be stronger in those communication aspects. I also took a bunch of coursework on teaching because teaching and instructing was an interest area for me. I went on for my master's degree in meteorology at Penn State University. There I worked with Dr. Jenny Evans on the extratropical transition of tropical cyclones. And as a part of my master's project, I was tasked to model a particular hurricane with and without satellite direct wind data to determine any differential in the output of the model. Did the model do as good of a job with or without those satellite winds? So data assimilation of satellite winds wasn't a language I spoke as an undergraduate, but it certainly became one when I was working through my master's degree, and understood that satellites could have a contribution to weather forecasting beyond just looking at the cloud pictures and seeing what was ongoing with the weather, that satellites are ingested into our model data and become part of that initial conditions that helps drive model results. When I graduated with my master's. I went into my career from there, and I'll get into my career side in just a moment. So we'll pause on that. But I came back for my PhD much later. I guess much, I don't know how many years it takes to define much, but I started my PhD 8 years after I graduated with my master's, after I was 8 years into my career. And there I did take more of a climate turn with my PhD from University of Nebraska, working in climate assessment and impacts, a degree that was focused on not just climatological assessments, but also communication of the results and how communication itself is a tool. I once again will echo Joseph that networking throughout that process was important. It isn't the only thing that gets you through a door, but sometimes it does get you into a door, or at least brings you to the door so that you can knock on it. So when I was in the program at Central Michigan University, that was a very small meteorology program. We had 1.5 instructors, basically one dude who taught almost everything, and another faculty who taught 1 or 2 courses. So I didn't have a lot of exposure. I knew that being a student intern in the National Weather Service was a thing, but at that time I actually wasn't all that interested in working in the National Weather Service. So I was looking for other opportunities and took a research experience for undergraduates internship at the University of Oklahoma. And that's where my world really widened to understand the range of possibilities and opportunities in weather across the enterprise. Like many people who don't have a lot of exposure to the field yet, I knew there was the National Weather Service. I knew that there were faculty members who taught meteorology, and I knew there were broadcasters on TV, but I didn't have a whole lot of awareness of everything else that existed out there. Even as far as understanding, for instance, that NASA had a significant weather and climate arm. Not to mention the private sector of meteorology, which has grown substantially over the last, couple of decades. So making that connection at that undergraduate internship was important for me. I also had a mentor there, and my mentor happened to have had all of his degrees from Penn State. So when I talked to him about graduate school, of course, he recommended his alma mater. And Penn State hadn't really been in my list of interests at that point. I had a couple of other schools identified, but he suggested I give it a chance, just apply, just visit, see what happens. And sure enough, that ended up being what I chose out of the options that I had available to me, which brought me to working with my advisor at Penn State, Dr. Jenny Evans. I'm grateful that I had her as a mentor, as a female in the meteorology profession. Understanding the challenges of being a female in the profession is important, and to have a mentor who could not only push me academically, but help grow me as a person was critical to my development. Dr. Jenny Evans at an AMS, an American Meteorological Society meeting, introduced me to a colleague of hers, Bob Livesey, who had been at Penn State a long time before and was working in climate in the National Weather Service. And so when I applied on a job at the National Weather Service, it happened that he was the hiring official. That part was kind of by accident, but it helped me understand who the person was that I was applying to, even though I didn't fully understand where in the agency this group was that I applied to. So again, that connection helped me get to my path. And then in my first position in the National Weather Service, I had the opportunity to work with the person in a professional capacity who would later become my advisor at the University of Nebraska and help me navigate admissions to a graduate program long after you've graduated from undergraduate work, and help me identify funding sources and such. So my current position within the National Weather Service allows me to train our workforce and also to be the two in research to operations. In other words, we sit at that nexus of the new information coming from researchers and applying that in forecast practices within the National Weather Service. So it is on us to stay tuned to emerging practices and research to monitor what's coming through peer review, to take the information that's vetted, and to look for the opportunities to improve and grow what we do. So we can go to the next slide now, Joseph. And let's talk a bit about that winding path and how I got to where I am. So my first position within the National Weather Service was at our headquarters in the Washington, D.C. area. And it was in the climate program where my role was a lot of people work. It was engaging in partnerships. It was creating training and helping our weather service offices know how to communicate about our climate information. But it also required me to gain some knowledge pretty quickly in climate as we do it in the National Weather Service, which means understanding how the Climate Prediction Center, for example, tracks and detects the El Nino Southern Oscillation, or ENSO, which, by the way, is done substantially, not completely, but substantially with satellite input. And then help our offices be able to understand and communicate where we detect those signals and how they factor into the Climate Prediction Center's analysis and forecasts. I stayed with them for a few years and then moved into forecasting, the thing I didn't think I'd ever want to do. I actually literally told somebody when I was an undergraduate, I told somebody very high ranking in the National Weather Service who had joined me at the bar that I was never going to work for the National Weather Service, and I certainly was not going to be a forecaster. And as luck would have it, I crossed paths with that same person a few years later when I was working at headquarters and about to move to my position in a forecast office, and she remembered what I told her. She remembered that was me. So be careful what you say. Be careful about saying never, because you just never know sometimes where your path will take you. I wouldn't have considered it at the time because I didn't understand what it entailed. And I didn't understand how that position would help me grow as a person and in my career. So when I worked in the forecast offices, I worked in 2 different offices and combined for a total of 13 years. In those positions, we incorporate quite a bit of information into our forecast process. And that includes everything from our forecast models for weather, which, as I mentioned, ingest satellite information as a foundation, and also using and diagnosing the observational and whether it's remote or in situ platforms we have available to understand the atmosphere and make both short-term and longer-term forecasts. I happened to be working in forecast office around the era that our satellites were upgraded through the GOES-R and GOES-S upgrades, which means I was a part of the cohort that had a crash course in expanding our purview of what satellite products we could have from basically 3 things: water vapor visible and IR, to a suite of 16 channels, dozens of applications of different color curves and layering of information to help detect everything from severe weather to fires and dust and moisture gradients and a number of helpful meteorological factors that help our forecasters make their decisions. I was not involved in creating satellite training at that time, but the lift on creating that training had to be substantial because it was a large endeavor to train the workforce on using such a wider array of satellite information than we had been used to using. But I did move into training. That was a little over 5 years ago. And now I do get to work in applying these things quite a bit. My particular focuses on training include climate, but also within the severe weather program, part of what we're working on is a paradigm that we're calling data fusion, which means we're taking data from multiple sources to help feed those warning decisions. Specifically, we know that our forecasters look at radar when they're going to issue a severe thunderstorm or a tornado warning. We also want them to look at lightning data. The GLM that Joseph mentions that he works on is very important to warning decisions now, as research emerges that shows us that lightning jumps can be a precursor to intensification of a supercell. And that gives our forecasters even more lead time to say that this may become severe or has the potential to become tornadic. We also have a satellite-derived set of products called ProbSevere, ProbSevere, and ProbSevere highlights where storms may be intensifying or weakening and where there is the greatest potential to produce hail or damaging winds or other severe weather parameters. And our role as trainers in the National Weather Service is to help our workforce not just become aware that these are available products, but to become comfortable with them and make them part of their workflow so that what used to be very new and shiny and over here as something a gee whiz to look at becomes another critical piece of information to look at in order to make forecast decisions. And by the way, some of those become especially important for parts of the United States that are not covered so well by radar. We do have quite a bit of land area that doesn't have radar coverage because it's blocked by terrain or because the radar that closest serves it is distant. So it's important to us to have these multiple sources of information to make those decisions. I'm going to drop a link into chat when I'm done talking. That is going to be a link to our training products. Our webinars and our interactive cases that we can work on our simulators, those are in-house only. But anything that is an internet module is open for anybody to take. And I think that is a critical piece of information. I really wish I had put it on the slide and I completely forgot, but maybe Joe can plug it in there for me and share it with others. The training includes the basics of radar function, and it includes the basics of how to issue warnings. And maybe those will or will not be so interesting for you. But if you look in our warning operations course for severe weather, you'll find quite a bit of training in there on using satellite information. And there's another program within NOAA or funded by NOAA called the VISIT program that additionally produces quite a bit of training on using satellites. And all of these are recorded, placed on the internet where anybody can take them. Because while it's important for us to train our workforce on using these products, it's also important for us that the rest of the weather community has this information too, so that they understand the basis of our decisions and so that others can have access and become fluent in the language that we are using of the factors that go into our forecasts and warnings. So I will drop that link in there. I always put my future as a question mark. I love training. I have that background in teaching that I mentioned. I get to do both weather and a bit of climate right now. You never know where your path is going to take you, though, and you never know what's next. So maybe I'll do this for the rest of my career, and if I do, that's great. Maybe something else lies ahead, and if it does, that's great too. But I think, as Joe has alluded, and Sherry too, it's important to have the interactions that keep you in touch with other people who are doing related work, or honestly, sometimes even work that doesn't seem so very related, but just seems interesting, because perhaps this other interest of yours that overlaps just a little bit with what you currently do is the next thing that you'll end up pursuing. So with that, I'm going to take a breath, make sure there is time for any questions, paste that link in, and then I'm going to be on for the rest of this session. So if anybody has questions, you can put them in chat or Q&A, and I will get to them. Joseph, you're on mute, I'm afraid.
I just saw that. Thank you. Thank you so much, Barb. We really appreciate your perspective. Let's see if we have any questions. Not yet. I see your link in there, which is awesome.
And Joseph, if you want to talk about the break now, if you want to unshare your screen and put it back up again, we can go ahead then and add Barb's link to the training slide. Or if Barbara, if you would like to add any additional information on that slide directly. Since Joseph is presenting, it doesn't update while he's presenting. So he would not present, and then come out of present mode and then put it back into present mode again.
Okay, Sherry, you want me to come out of present mode?
Well, if we want to let everybody know, we're going to take a 5-minute break here and then talk about finding different jobs. Where are all of these opportunities? We've talked a lot about different ways that people can use satellite data and how people got into these career paths, which are not straight lines. And even if you know what you want to do, how do you get there? So we'll do a quick 5-minute break, and we'll go back on at, what is that, 2:19, and we will finish up with places to look for jobs and organizations and directions that will help you get there. As we're waiting to get started, Alicia, if you are there, we'll talk about different ways to find training and internships during the next session here. But I have to tell you, I work with someone on the Gozar Data Jam whose degree was in meteorology and she had a minor in film. And here we are talking about how to do advertisements and how to visualize the data, which is one of the challenges on this Gozar Data Jam. And she's applying her film degree with these little videos and things that she is doing. So your art degree is very helpful in creating images so people can see what is happening in their location. At some point, we will even talk about using Python to create images to communicate this message. So having the art degree is actually a bonus in meteorology. All right, so we do have another question in here, and I know we're running a little bit behind, go figure. We have a lot of information to cover in this last bit. The question in the other chat is, what advice would you possibly give to someone who is new to the field of forecasting, who is still adjusting to the ropes of the post? That one, I don't know if Joseph or someone, if you want to answer that, to type that answer in while we're continuing, or we can talk about it as we talk about the positions that are available on the one of the future slides. So either way, that would work.
Yeah, maybe I can answer that on a future slide. Yeah.
Okay. And then since we are 20 after, let's get rolling on how to look for the jobs. Can you advance? Perfect. Thank you. Okay, so where to go, how to look for a job or an internship. Wayne commented on the World Meteorological Organization and the metrics and the standards that WMO puts out will help guide a lot of meteorologists on what is needed to be a skilled forecaster. So again, we will put all of these links into a document. They'll be posted on the website as well. And the disclaimer that in this section, any of the companies or organizations that we mention are non-endorsements. And so I wanted to get that out of the way. Another organization that you may not think of right away is the United Nations. It's again another global organization that is going to have opportunities and an interest in protecting the populations from severe weather, flooding, droughts, climate, agriculture, and that sort of thing. So keep those thoughts in mind when you're looking for a job. Kind of think outside the box a little. Next slide, please. Oh, that's you. Unmute and I'll mute.
So we want to talk a little bit about the cooperative institutes, which are in the United States. So NOAA, the National Oceanographic and Atmospheric Administration, facilitates several cooperative institutes, which are joint ventures between NOAA and major universities. And essentially, these cooperative institutes focus on research into different atmospheric phenomena, and they all have slightly different purposes. And we'll get into a couple examples on the next slide. But overall, they develop new tools and techniques for operational uses of meteorological and satellite data across NOAA. And they offer unique opportunities to get involved with satellites on specific projects that pertain to that specific cooperative institute. So the members of each cooperative institute are employed by the university, but they work to fulfill some of the goals that NOAA has for advancing its research. So they're often funded by grants from NOAA in order to do specific research. So as an example, I work for the Cooperative Institute for Satellite and Earth System Studies, or CISES. And CISES covers many different research areas, from sensor calibration and validation, CalVal, to new product development, to data stewardship, and even societal impacts from hazardous weather. So a few more examples of cooperative institutes. There's the Cooperative Institute for Research in the Atmosphere, which is based out of Fort Collins, Colorado, where Colorado State University is. One of our people who's been very helpful on the AMS committee to get this short course running is Jarrell Torres, who works for CIRA, and he created the website for this short course. So that's just an example of something that you may be doing at one of these cooperative institutes. And they really focus on interdisciplinary research to bring in skills outside atmospheric science, and then transitioning techniques between pure and applied research and operations or day-to-day forecasting. One of the cool things that CIRA does is they have this RAMBI slider, and this slider allows you to look at different satellite imagery from geostationary and polar orbiting satellites. So this example here is a GOES 16 or GOES East image, which covers North and South America, but we can also switch to, say, for instance, the JPSS system of satellites. And this shows the polar orbiting or the low Earth orbit satellite observations as well. So just different perspectives of the same thing. So we're going to paste this link in the chat. Let's see here.
I was answering a question, sorry.
That's okay.
I'll do it right now.
I just pasted it. So that will take you to the what we're currently looking at with this JPSS, but you can click the satellite button and change what satellite you're looking at. You can click the product button and change what product you're looking at. So from the VIIRS instrument, we can do a dust, which won't show much, but it does actually show there may have been some dust up in that area in Canada as well. So this is just an example. So we encourage you on your own time, maybe after this, to play around with this. This exposes you to some of the different satellite products, and maybe that can spark your interest in understanding what your interest may be in the satellite enterprise. So another one of the cooperative institutes is the Cooperative Institute for Meteorological Satellite Studies, or CIMS, at the University of Wisconsin-Madison. And CIMS runs a satellite blog where they share detailed perspectives from experienced scientists who are working at different cooperative institutes or centers. And they, in that blog, they bring in their everyday expertise working with the different satellite products, and they explain and showcase recent impactful weather phenomena to a general wider audience. So it's a really interesting website to be able to see, to relate these satellite observations with what's going on weather-wise. So it's a really great way to expose yourself as to some of the work that's being done with satellites. And then finally, we want to mention the University of Oklahoma. They also host a cooperative institute. It's the Cooperative Institute for Severe and High Impact Weather Research and Operations, or CIRO. And they promote collaborative research on improving the understanding of severe weather events and helping to produce better forecasts and warnings as well. So CIRO, just as an example alone, has over 200 employees and over 25 million US dollars each year in annual funding. So, there's lots of opportunities, and that's just one cooperative institute. There's lots of positions and opportunities to get involved there. So we also want to briefly mention some of the meteorological institutes abroad which are available. Many countries operate their own institutes for specialized research into the atmosphere. For example, Korea has the National Institute of Meteorological Sciences. Japan, the Meteorological Research Institute. There's also the Chinese Academy of Meteorological Sciences, and just as an example, the Indian Institute of Tropical Meteorology. So some of these are more focused, some of these are more broad, but we encourage you to see if your country or area or region has some sort of meteorological research institute, and try to reach out to some of the people there who share the same interests as you do, and they may be able to put you in touch with people to further your career, or be mentors for you as you try to navigate the satellite or weather enterprise. Sherry, I think this one is you.
And I'm on mute. Sorry about that. Satellite data. As Barbara mentioned, there's a lot of satellite data modeling. The NOAA's Office of Environmental Modeling Center is where they produce a lot of the models for the weather predictions. One of the goals is to have these models increase their forecast skill, and that includes adding satellite data to some of these models. And that's another way that you could incorporate Python. You can incorporate your coding skills and your interest in severe weather events, wave watches. There are a lot of opportunities to learn about the different modeling models and ways to use satellite data. One other example of that is, you've heard about sargassum. Meteo France is actually using GO16 data in their model to help track the sargassum mats that are floating out in the ocean. Climate applications, Barbara mentioned that as well. There are many different archives and many levels and layers of data that have been collected over time. Coding, Python has also been mentioned, as Wayne talked about doing some visualization using Python. Another place that you might want to look at different presentations is the Satellite Book Club seminar. Now, this is National Weather Service based. However, the link that I will put into the chat, also anyone who is non-NOAA can access these YouTube videos of these Satellite Book Club sessions. They are half-hour sessions that forecasters and others might talk about a specific incident, what they thought would happen, what actually happened, ground truthing. Great quick lesson in understanding some of the data and how to apply it. Barbara also talked about the social science side of all of this information. We can predict where something's going to happen, but to preserve lives, to protect property, you need to communicate that out, and you need to have the public understand it and be able to react to it. So within the Weather Service, or within NOAA in general, there's the Warn On Forecast program. A program like that will be building social science, will be connecting forecasters with prediction and how to communicate the forecast out. In a situation like that, money is available. The United Nations has just put out an early warnings for all initiative. And already this past week, that has come up in 3 and 4 emails as to how are we going to address this from a training perspective, but from a project perspective. There are plenty of areas that don't have radar. Can they use the satellite data to get a warning out? How do you get the warning out? Again, if you're looking for a job and you're interested in early warnings and predictions, look to the United Nations, see what projects they're promoting to recruit people to help in this initiative. Let's see. And then next slide, please. Other non-traditional industries to consider. We're talking a lot about federal government organizations, meteorological organizations, but armed services, Air Force, Navy, Marines, they all need to understand the weather for safety of the ships, for, unfortunately or otherwise, exercises, flying the planes, wave height, right? For landing a ship on an aircraft carrier, you do want to know what the wave height is and be able to predict that. Media, broadcasting, energies. I did a very quick search on meteorologists. I think it was through Indeed, and Dominion Energy is looking for a meteorologist. Energy and utility companies are also would hire meteorologists. Transportation, land, sea, and air, again, the shortest distance for a flight. You know, if you need to go around a storm, how do you do that efficiently? How do you predict the storms? Again, as Joseph had said, many different ways to use forecasting and meteorologist skill. When you're looking for a job, think outside the box a little. You don't know where that path will take you. Next slide. So government contractors, as I mentioned, I'm a government contractor. And what that means is that the federal government put out a request for an organization to manage employees to work on a project. So I work alongside federal employees. I work on a project that goes our satellite training. There are many feds that I work with in different roles as well. There are advantages and different disadvantages on being a federal contractor for the US government. The contracts could be 5 years with multiple option periods, but when that option period is over, there needs to be a recompete. The company you're working for may or may not get the job, win the next contract. Oftentimes you've got enough experience that if your company did not win the contract, the new contractor may pull you on or absorb your company into the fold as a subcontractor. So there are some advantages and disadvantages. My advantage was I worked for the Weather Service. My contract company had this position opened. I liked the job. It was a great fit for me, and I slipped into it. There are a lot of large and small companies such as Lockheed Martin, Ball Aerospace, and we can include these links later on. But I wanted to point out, if we can go to the next slide, a lot of information about these large companies. This slide was presented as from the GeoXO program office and talking about this new satellite that's going to launch in 9 years. We have 2 satellites that are going to be similar to what we've got now with goes east and west, and a central satellite that will need to be built. All of these satellites will have improvements in some of their instruments, increasing the number of bands on some of the instruments. During the conversations about getting an imager on one of the satellites, they pointed out that the imager selection was announced March 2023 for a company to build the new imager. The second bullet is sounder RFP, request for proposal for a company to work on the sounder. That request for proposals is closed, and that contract is going to be awarded in August 2023. So any students, August of 2023, you jump on, go to the next slide, please, and you can hit NESDIS News, and NESDIS will announce who has won this contract. In the case of the GeoXO imager, they announced that L3Harris won the contract, $765 million worth in US dollars. So here's an opportunity. Again, the funding is not all in people. It's obviously instruments, locations, etc. But you know L3Harris is going to need help building this next imager. Although the company is in Fort Wayne, Indiana, the jobs are not going to all be in Fort Wayne, Indiana. So if you go to L3Harris career page and you take a look and you search satellite, you can find some of this information. And since we're tight on time, we're just going to quickly run through. The similar situation with JPSS. I wanted to just point out one of the NESDIS News comments had said Peraton had won a contract. I jumped to their career page to see what they had. They have no jobs available if you don't have clearance. However, when you select no clearance, they've got a virtual hiring event later on this month. This is, again, it is a US organization, and they list at least 6 different states where they're looking for people to be hired for different positions. And there's a large range of positions and what they're looking for as well. So keep digging when you're looking at these job postings and you don't see anything. Go to approach it a different way, and you may be able to find different opportunities. And next slide. And that's Joseph.
So we wanted to talk a little bit about the employees of the federal government and also state governments to show you a little bit about some of the different agencies and organizations you can be involved with. So this is a little bit US centric, but oftentimes there are parallel agencies for the country where you're existing or where you're looking for opportunities. So first, as an example, we've talked extensively about NOAA and the National Weather Service for forecasting and training, and also atmospheric research into weather and satellite data. We talked about NESDIS, who's responsible for the orbital maneuvers for the NOAA satellites and also validation for satellites. Also, there's NASA, right? NASA launches most of the satellites. They operate many of the many satellites. The imagery there, the image on the right-hand side is a composite map of all of the satellites which are operated by NASA. For example, you can see the Cygnus satellites here, which stands for Cyclone Global Navigation Satellite System. They focus on trying to capture the dynamics of inner cores of tropical cyclones. So what makes that satellite different is that it allows forecasters to measure the ocean wind speeds through strong convection, which was something that the previous satellites were not able to do because they would estimate the winds based on the ocean wave heights, and they couldn't see that through the clouds. But Cygnus is a joint venture. It's not just NASA. It involves many universities, principally led by the University of Michigan. But there was the Jet Propulsion Lab, part of NASA, the Southwest Research Institute, and Surrey Satellite Technology was also involved. So it's a unique example of public, private, and academic institutions all involved on that satellite project. Just as another example, there's the U.S. Department of Agriculture and Forest Services. They hire meteorologists to help predict dangerous evolving fire weather conditions and to help them protect life and property. And that includes state resources as well. So there's the CAL FIRE, which is the department in charge of preventing wildfire impacts in California. And there's a similar situation with the state of Maryland, there where I live, their Department of Natural Resources as well. In addition, the U.S. Geological Survey, Environmental Protection Agency, there's too many agencies in the United States to list them all that hire meteorologists, but similar agencies might exist also in your area. So we encourage you to do some research, check that out. And then finally, another example of a federal employee or government employee is emergency management. So they are the people who are coordinating the response to disasters, and they require satellite data to understand the impacts of the weather that's happening, and then also keep the people who are responding safe from other occurring weather hazards, and understand the damage that's been done. Satellites can give you an idea of what areas were most impacted by severe weather.
And thank you. I see Octavio's comment in the chat regarding geophysical engineering positions. There are opportunities internationally for different positions. Joseph, at some point, will talk about a bilingual position that's being posted for the National Weather Service, the Weather Prediction Center. So there are different places to look for international jobs. U.S. jobs, USA Jobs will list the federal positions. Again, you would often need to go to the companies that have won contracts for additional postings as well. The listservs from many of these organizations, you might see job postings in there. Networking is huge in trying to find a job. AMS has a career center. Job postings are there. AMS will be more of the American Meteorological Organization. AGU's career center, when I jumped on their website, it was actually definitely more international with positions that are posted. UMETSAT is in the European Union. And again, a variety of international positions are also available there. One thought is to attend conferences. AMS has their annual meeting in Baltimore in January, and networking. They spend the weekend before the annual meeting with student and early career networking events. The weekend is focused on students finding jobs. There's mentoring sessions. So there are ways to do work internationally as well. Create a LinkedIn profile. That will be huge in showing your strengths and what your interests are, and start looking for like-minded organizations on LinkedIn. Noah Nesdis does post jobs on LinkedIn as well. That is how I found my job with STC. I put in some keywords and was able to find the position. And because we are running short on time, I'm going to skip the next slide, which really talks about networking again, and we will continue conversations such as this. Please feel free to email me. Or email Gary, and he can forward the information to me if you've got additional questions. And we'll provide links to all of these sites on the website. And then I'm going to hand it over to Joseph to wrap up here quickly so we can.
Thank you, Sherry. So one thing we wanted to quickly talk about is, organizations are really puzzle pieces, and sometimes you have to figure out where those puzzle pieces fit in with each other to understand where you want to contribute to a certain organization. So this, as an example, is from the Great Lakes Environmental Research Laboratory, which is part of NOAA. And, they're made up of many different offices, each with their own responsibilities and staff, and you can see on the chart there, from observing systems to quality and safety, environmental compliance to IT. And it's not just one particular area. They've got a lot of different people with a lot of different diverse responsibilities who make that project happen. So there's lots of different disciplines that are involved, from operational meteorology to research to training to depending on your organization, there's international relations and just accounting positions as well that'll let you be sort of indirectly involved with the satellite enterprise there. So discovering where you might fit in an organization and which jobs to apply for is sometimes half the battle, just to understand what's out there in particular for you to set your sights on and direct your energies toward. So we want to talk about USA Jobs. USA Jobs is the federal government hiring website. They list jobs and paid and unpaid internships that are through the federal government. So part of what makes USA Jobs unique is that you can search there using keywords, and some of those keywords are actually assigned for different categories or types of jobs by the US government. So they use position codes, a 4-digit code, to relate to specific positions. For example, the position code for a meteorologist is 1340. And if you were to go to USA Jobs and type that in, you would get all the positions which are specifically for meteorologists there. Another example is the code 1301 for physical scientists. And physical scientists can really be anything. It doesn't necessarily mean that you're doing physical science the whole time. It can be anything from management to laboratory work to forecasting. So I definitely read the position, read the description of the position, and understand what it's entailing. The job title does not necessarily provide the best indication of what your responsibilities are going to be. but some positions will also give you ahead of time a list of questions that they're going to be asking as sort of a pre-screening or selection process. So I encourage you to read those questions ahead of time as well, so you can familiarize yourself with what's going to be expected of you, and then also include some of that information specifically on your resume. They're very strict about how they accept resumes. So if you don't mention things in particular, then they might not pass you through the selection process. And we're going to have a resume example here coming up very soon. So, what is that federal resume? Is it different from a traditional resume? Well, you have to be a little bit more detailed, a little bit more specific, and it may be a little bit longer than a traditional resume. Things that are, for example, things that are required on a federal resume include items such as the number of hours you worked per week and the contact information for your supervisors. You can't just put, there was a complication where you can't just put full time. You have to actually put 40 hours worked per week, which they were being sticklers on for some unknown reason. But you can build your federal resume on USA Jobs, or you can create it yourself in different word processing and tailor it for your individual applications. And remember that you don't have to meet necessarily all the listed requirements to be qualified for that job. You can be the ideal candidate without necessarily meeting all of the skill sets. And they're going to measure you against the other candidates who apply and determine if you're eligible to be interviewed and if you're eligible to be hired. So let them make that decision as you go on. However, you have to get past that algorithm. So your resume should have as many of the words that you can fit that fit your positions from the job description. And think outside the application of your skill set. So if it says you must have 3 years of experience working on a team, if you were on a sports team for 3 years, you could list that maybe. But they really, it's not just about having the skills, but having the passion for that position as well. You want to be confident in who you are, express yourself clearly, and show that you're going to be a hard worker for that position. So we wanted to show quickly a resume example from USA Jobs. This is actually a before and after of my own personal resume that I had written at 2 different times apart from each other. And the one on the left is the before entry for my work with the National Weather Service, and the one on the right is the after entry for my work with the Weather Service. So there's a few things to take away from here. One is that the right-hand side is clearly more legible, more concise compared to the left-hand side. The entries are shorter, more straight to the point. One of the things that I realized was that there are just long strings of text on the left-hand side that are 3, 4, 5, 6 lines long. And that is not really, not necessarily readable, and it doesn't necessarily make the best impression when someone's trying to go through your resume. So when I reformed it to the one on the right-hand side, for example, taking this fire weather program leader position that I had at WFO Goodland, that is a special skill that I was able to hone in on when I was working for WFO Goodland. And so to have it as like the 6th or 7th bullet point probably wasn't the greatest idea. So I moved it up to that 3rd bullet point to show its significance, and also shortened it significantly to make it more readable. If you're applying for an organization where you're already internal to, you may not necessarily have to give as much detail to describe a certain aspect of your work, because they may already be familiar with it. And then also something else that I included was the hours worked per week, which I didn't have on the first one. And then also the salary that I earned, which is something that USA Jobs required that I didn't have on the first one as well. So this is just an example of how, you want to include as much detail as possible, but you also want to keep it concise. So somewhere between 2 and 3 pages is often a good length for a federal resume. We also want to briefly mention that there are some international organizations or agencies to get involved with satellites. We've talked about EUMETSAT here, which is the European Satellite Agency. They have their job vacancies list, which includes everything from civil engineers to remote sensing scientists to data processing, ground operations, mission control, lots of different things to get involved with satellite observations. And then also, just as an example, there's the Korea Astronomy and Space Science Institute, or KASI, and that's a national research institute for astronomy in Korea, and they often develop, establish, and operate environmental satellite instruments as well. So this includes postdocs and then also full-time researcher positions at that institution. So one of the things we definitely want to hit on here is job recruiting websites. So this is a great way to find positions that are in the private sector as well as the public sector. So two of the good websites to look for when looking for jobs are LinkedIn and Indeed. And we've got examples from both of those here on the right-hand side. Both of them are great ways to find jobs specific to one country. A lot of times your country might have its own LinkedIn website, and then also you can search for other organizations on the Indeed website, and you can get valuable information from others who have worked there in the past and get their input on what it was like to work there, what were the pros and cons of working there, and that kind of thing. And it's not just for the United States. LinkedIn especially has a very strong international presence as well. So we encourage you to explore those websites to find what suits you. The LinkedIn example there in the center includes some private companies as well as public entities as well. One of them is a climate reporter centered in San Francisco. Another one is a broadcast meteorologist, which is something we haven't really talked about a lot, but that's another public-facing position where you're relaying timely weather info, and people, the public, rely on you to be a trustworthy source for them to get the weather safety information they need, like tornado warnings or blizzard warnings. So it's a very important integral part of that weather community. They're showing satellite data in a way that makes it more digestible for the public, which can hit home that weather message even more. And then finally, ZipRecruiter, that's only in the US and Canada, but they can often show more job opportunities, especially in the private sector. So this was the job that was mentioned earlier, the bilingual English and Spanish meteorologist training position. You're technically working for that private company, but you're fulfilling a need that is put out there by the Weather Prediction Center for someone who can speak both English and Spanish. So these are all three good websites to go to for that.
And all of these comments about looking for these different jobs, think about this as the right job for now, that this is not the rest of your life. It will set you on a path that you may not understand the path, or you may see your path. But please go ahead and apply for a job if you're interested in it. I do want to, in the last couple of minutes here, we'll wrap up. We will put a lot of this training information and these links on the website as well. And that's another way to expand what you're doing. The next slide is a quick advertisement for the Data Jam. And then this is for grad and undergraduate students. These teams of students are working on are learning how to use GOES-R data. So that's something, if you're interested in, you can do the QR code, or we can put that on the website as well. And the last slide, which is the wrap up of all of the short course sessions. So first of all, we all want to say thank you for everybody. We do know we have people in different time zones attending these sessions. If we are still working on rescheduling the GLERL training session, thank you for your understanding and us needing to cancel that. For certificates, folks who have attended 2 of the 3 sessions, we will be getting certificates out within the next 3 weeks or so. It takes a while for us to do that. If you have participated at least 1 hour in the sessions, then you are counted as attending. We will send out here the short course survey. Please take a moment to complete this survey. This helps us a lot in being able to plan future sessions like we will for mid-2024. There's always more training available. Gary McWilliams does a lot of AMS training and JPSS and GOZAR training. We will continue to add more information on the website. Jun, if you would like to say something here at the end, and or Gary, and thank you everyone again for attending the sessions.
Yeah, thank you, Sherry. Thank you, Ju. I actually listened, and for the most part, I wish when I was a student, I probably can say this for many of other students that I know, that we had this kind of the sessions that know how broad, how wide, and how big the discrepancy is, and the opportunity for the jobs in this area. I mean, no kidding, with all the SpaceX Blue Origin that's going up, there are lots of aerospace opportunities in a bigger picture. We do have students like graduate and work for SpaceX this year. So I would like to say this is a really a new emerging and a very growing area that looking for young talents. And the SADMAC team, our SADMAC team here, spent a lot of effort to plan this, and we try to really strive to provide a free service for you. I mean, for the training, for prior information. I hope you really enjoyed it, and then spread the good words for your colleagues, for your friends or classmates. If you feel we're doing good, if you feel this is something good for them to know. So with that, I just want to end up here. Thank you again, Sharon and Jill, and many others in the team to make this happen. Thank you. All right, bye-bye then.
Thanks, everybody.